Hello everyone, this is Mr. Wyrick, and today I'm going to go over the notes for 423 Part 2, the surface area of pyramids and cones. I'm going to be clicking through the notes over here and just talking you through them. So on slide number 2, we got regular pyramids. Whenever it's called a regular pyramid, that means the base of it is going to be equal on all sides. So an equilateral triangle, a square, if you have hexagons, octagons, whatever, if they're referred to as regular, it means that each of the sides is exactly the same. The lateral area of regular pyramids. So again, we're talking about what would be the label of something when we're talking about lateral surface area. When we're talking about pyramids, it's just going to exclude that bottom base. So it's 1/2 the perimeter times L, lowercase l, which in this case is the slant height. So you'll have to be working some right triangles here, some Pythagorean theorem, in order to get through these problems. The next slide shows you that little L, and again, it's kind of cursive, lowercase, you'll see it there. The surface area of the regular pyramid is 1/2 the perimeter times L, that slant height, plus the area of the base. So in this case, really, the reason the 1/2 is there is because we're dealing with a lot of triangles. Just like the face, every lateral face of a cylinder or a prism is going to be a rectangle. Every lateral face of a pyramid is going to be a triangle. So 1/2 the perimeter times the slant height plus the area of the base. If we're looking at the surface area of the pyramid, be sure to look and make sure on this next slide on number 5, if you want to look at some examples, make sure you know what it's talking about when it gives you the slant height versus the regular height. And then on that second one, it looks like we have a square base. So we have 13 for our slant height. We're going to have 5 for that line from the middle to the outside because the entire side is 10 and we need 1/2 of that. On number 6, the surface area of the regular pyramid to the nearest 10th. Again, you won't be able to get the full surface area on the one that's the pentagon because we haven't talked about area of a pentagon before. But we can get, slant height. We can talk about, the actual altitude. Okay. Lateral and surface area, a cone, starting on slide number 7. And again, it's the same kind of thing. We have pi times the radius times the slant height for the lateral surface area. And then the total surface area, you're going to have pi times the radius times the slant height plus the area of that base, the area of the circle, so pi r squared. A waffle cone is 5.5 inches tall. The diameter is 2.5 inches. Find the lateral area of the cone, round to the nearest 10th. This is going to be, again, that's diameter is 2.5. So to get the radius, you'll have to cut that in half. That's going to be 1.25. So 1.25 times, and you'll have to use the Pythagorean theorem, 1.25 and 5.5 to get that slant height. Then we take those, multiply that by the radius, and then multiply by pi. Okay, so go step by step, pretty carefully. Make sure you're using Desmos. Make sure you're using pi on Desmos. If we look at slide number 11, it says, here's what we did Monday and Tuesday. That's funny, I forgot to change that. Let's change that right now. So this is what we did on Wednesday. And then here's what we are doing today. So we've got all of the formulas there for you on slides 11 and 12 if you're still working your way through those. On 12.3, the worksheet that you're going to get, just make sure, rounding to the nearest 10th, rounding to the nearest 100th, whatever it says, use Desmos, use pi in there, and make sure you work your way through it. We'll go over a couple of them when I come back to class, and we will have a practice performance task. Good luck.